Another way of solving vectors is analytically. Say we have a vector, a random vector, like that. What we can actually do is we can break this vector up into an x bit and a y bit. And we can write that vector as an ordered pair, x plus comma y. Now, this may seem a lot of complexity, but if we use vectors like this, we can write down a vector like this, and it makes the maths a lot easier, especially when we're doing more complicated processes than just straight addition. So let's take an example. The y amount, if we take an example, let's make a vector, this is 10 long, this is going to be the x amount, this is the y amount, and let's make the angle 30 degrees. No particular reason. The x amount is always going to be h cos theta. So that's going to equal, h is going to be 10 cos 30 degrees equals 8.66. The other way, and y, the y component is going to be h sine theta, which is equal to 10 sine 30 degrees, which is equal to 5.00. Now, we then write that as, well, when we write an ordered pair, the x bit always goes first, 8.66, comma, 5.00. So if this is vector A, then A equals, and this is a perfectly valid form of writing down a vector. In fact, we often call those vectors in physics and engineering and things. So when we write down a vector like that, we work out the x bit, that goes there, the y bit, and the x bit is always h cos theta, and the y bit is always h sine theta. Okay, so let's take an example, a fairly simple example that we did before, or I did before. So to find the treasure, walk 100 paces east, 75 paces north. So the first vector is going to be 100 paces this way. And if we look at this, remember as a rule, up and to the right are both going to be positive. So if I look at this, this is A, this vector is going to equal 100 paces, 100, and there is no, it doesn't go up at all, so there's zero y component. So A equals, B equals 75 paces that way. So B equals, B has no amount that way, 0, x, but it's got 75 y. So A plus B, and this is where the trick is, A plus B, to add them together, all you do is you add the components together. So we add 100 plus 0 equals 100. And then we add the y's together, 0 plus 75. And if we had any z components, we can do that as well. Okay, so that is a vector. Now if we want to convert that back into a triangle form, what we have is, if I draw this in, just sketching this in, we've got 100, 75. I end up with a vector like that. This is my vector. How do I find? Vectors are always set up, this system is always set up so that's a right angle. how do I find the length of the vector? To find the length, use Pythagoras. Use Pythagoras' theorem. So, h is equal to root of a squared plus b squared equals root of 100 squared plus 75 squared equals 125. It's a plus b equals 125 paces. To find the angle, use trig. In this case, we're going to use SOHCAHTOA. SOHCAHTOA. And in this case, we've always got the opposite, the adjacent, so we're going to use tan theta equals opposite over adjacent. I want to find out theta, so I have to use the tan inverse function, so I go theta equals tan inverse, and we're always going to use, in this case, to find that angle, we're always going to use tan inverse opposite over adjacent, which is equal to tan inverse opposite is 75, adjacent is equal to 100. So tan inverse at this point is what they invented these things for. Tan inverse 75 divided by 100. Don't forget the brackets, equals 36.87 degrees. So I can now write the vector down as a plus b equals 125 paces, angle 36.87 degrees, or I can also write it down as 100,75. Both ways are correct. So unless it explicitly says one way or the other, you can usually get away with either. In my test, I want you to see this. I want to see both, just so I know that you understand what's happening. Okay, so I'll do a more complex example in a second, like we did with the graphical version. But the basic technique is we're going to break into components, break the vectors into x, y bits. That's what we did up here, x and y bits. Add the x bits. Add the y bits. Then what we do is use Pythag to find the length. Use Pythag to find the length. Use trig to find the angle. And you may think this is a rather complex way of going around things, breaking things up, but especially when we get into much more complicated vectors or three-dimensional or four-dimensional vectors, this actually does turn out to be a much easier method.